Hi, this is Tanya Chu. So this is to answer a request of one of the students here, which has a problem in one of the IGCSE Physics paper. So in this video, I am going to fulfill that student's request. In this video, I am going to discuss Cambridge IGCSE Physics Paper 2 Multiple Choice Extended Paper. The paper that I'm going to discuss is May-June 2023, Paper 21. Let us get started. Look at the first question. Which vector diagram correctly shows the force Z as the resultant forces X and Y? So whenever you see a vector triangle is being drawn here, this is called vector triangle. All you need to do is just to recall one rule. The rule is called tip to tail rule. What do I mean by tip to tail rule? Meaning to say that you have to imagine that you have an arrow. This is an arrow. So the pointy part of the arrow is being called the tip of the arrow, and the back of the arrow is called the tail of the arrow. And second step, look at the question. Question asks you to determine the resultant force. So the resultant force is Z. Now, but X and Y, it is the combination of X and Y, the forces of X and Y, that gives you the resultant force of Z. That is why X and Y must follow tip to tail rule. Now, second step, since the diagram is being drawn for us, right? Let us identify. This is X, this is Y. Can you see where the intersection of vector X is meeting the intersection of vector Y? This is where they meet. This is called the tail of X is meeting the tail of Y. So A cannot be the answer because this is a vector triangle. Right, I better write it down. This is a vector triangle. For vector triangle, you have to follow the only rule, which is called the tip to tail rule. That means the tip of X must be combined with the tail of Y, or vice versa. Right? Now look at B. Look at B. I'm going to use highlighter so that you can see. Could you see the tail of X is being combined with the tail of Y? B cannot be your answer. What about C? Could you see that the tip of X, look at the arrow of the X. X is going up, meaning to say that the tip of X is meeting the tail of Y. Y is going away from X. This is what we call tip to tail rule. And look at D. Tip of X is meeting the tail of Y. Same thing here. Now, it cannot be A or B, but it could be C or D. Don't worry about that, okay? Tip of X is meeting the tail of Y, and the resultant, for resultant force, you have to start from the tail of X. Once you have finished drawing your X and Y to draw the resultant, you have to recall which vector that you first draw. Vector that you first draw, okay, the tail of X must be meeting the tip of Y. Could you see D is that the tail of Z? Okay, for the resultant vector, let me draw it out, yeah? This is X, the tip of X is meeting the tail of Y. This is X, this is Y. This is what we call tip to tail rule. Let me erase that and draw it nicer. This is what we call tip to tail rule. Okay. And if you want to draw a resultant vector, okay, the tail of the first vector, you draw all the way to meet the tail of the second vector. So which one gives you the answer? Okay, I believe that you can see the answer right away, right? D is the answer. Now, the second question. An object falls towards the surface of the earth. The object is falling at its terminal velocity. Now, when you see this word, each and every question given here, there must be a hint behind it, right? So you seek for the hint. First thing, look at the hint. Oh, the hint is terminal velocity. What is terminal velocity? Terminal velocity means the maximum velocity of an object when air resistance. When you see the word terminal velocity, that means air resistance is present. Air resistance balances weight of object. So when the air resistance is balancing the weight of the object, the resultant force, right? Resultant force acting on the object is equal to zero. Because after all, there are two forces that are acting on the object. Let's say this is an object. Weight of the object is always acting downwards because object is falling down. The ground is here. Now, air resistance is the opposing force by air particles. When the object is falling downwards, the air resistance must be acting upwards. That is what we meant by opposing force by air particles. This is called air resistance. Right? When the terminal velocity is being reached, that means the air resistance is balanced by, or the weight is being balanced by the air resistance, which gives zero resultant force because upward force is balanced by the downward force. Right, so when the resultant force is equal to zero, F equals to ma. No resultant force, no acceleration. Right. Maybe you wonder, why do I say this is called, why do I define terminal velocity as maximum velocity? Because when an object is dropping, the speed of the object is going to increase. With the presence of air resistance, when the speed is increasing, the magnitude of the air resistance will also increase. And the magnitude of the air resistance will increase to a certain value, which is equal to the weight, and it would not increase further. That is where the speed of the object stop increasing. So the object will drop with the same speed until it reaches the ground. Right. Now, let us look at which statement is correct. A, there is air resistance and the acceleration of the object is negative, never negative. Right, because the acceleration of the object will keeps on increasing until it reaches zero. B, there is air resistance and the acceleration of the object is zero. This is true. At terminal velocity, there is no acceleration. C, there is no air resistance. How is it possible, right? C and D are wrong. Now, question number 3. The graph represents the motion of a vehicle. What is the distance traveled by the vehicle? Like what I say, seek for the hint. The hint in this case is that distance. They ask you to calculate the distance. And second step, how do we calculate distance from the graph? What is the graph given? The graph given is speed against time graph. For the speed against time graph, the gradient of the graph represents acceleration, whereas the area under the graph represents the total distance traveled by this vehicle. And you have to bear this in mind. This is a very tricky question at the same time because this is a straight line graph. This graph is called a straight line graph. To find the area of this graph, it is actually equals to area of triangle. So you have to recall a little bit of math here. The area of triangle is half times the length, right, times the height. Right, the length is 400 seconds and the height is 20. So use your calculator. You should be able to get 4,000 meter. C is the answer. Number 4, on the earth, a spring stretches by 5 cm. When a mass of 3 kilograms is suspended from one end, the gravitational field strength on the moon is 1/6 of that on earth. Which mass on the moon would stretch by the spring? By the same would stretch the spring by the same extension. So I have to do it one by one. This is on the earth. Okay, this is a spring, and then this is a mass, which is 3 kilograms, and then stretches, that means the extension given is 5 cm here, and that's it. And this is moon. The gravitational field strength of moon is equal to 1/6 to the gravitational field strength of earth. Gravitational field strength of earth is equal to 9.8 meter per second square. So I'm going to write it nicely, 9.8 meter per second square. right? So the gravitational field strength of the moon is 1/6 times 9.8, which is equal to 9.8 divided by 6. You get 1.63 meter per second square. Now I'm going to do it one by one. This is like simultaneous equation, right? Equation that you need to solve here. I am going to use Hooke's law because this is related to spring. F equals to kx. This is Hooke's law. And the force, this is the gravitational force because the mass is pulling the spring downwards, right? So I'm going to write F is equal to mg, which is equal to kx. Now, from this equation, I would like to find the spring constant for this particular spring. Right, the mass on the earth is 3 and the gravitational field strength is 9.8 equals to the spring constant times the extension. I'm just going to put it 5, right? Or if you want to convert it, it is even better because the gravitational field strength of Earth is meter per second square. So I'm going to change this 5 cm to meter. I'm going to convert to meter. So when I convert to meter, I need to divide by 100. So I get 0.05. Now the spring constant that I got, 3 times 9.8 divided by 0.05. Now the spring constant, the value of the spring constant is 588 Newton per meter. Since this is the same spring being brought to the moon, that is why the spring constant remained constant. Now, using the same equation on the moon, so I'm going to write down F equals kx. F is mg, which is equal to kx. Now I need to find the mass. What is the mass? When the gravitational field strength is 1.63 and the spring constant is the same spring, and then times the same extension, 0.05. Now mass will be equal to 588 times 0.05 divided by 1.63. So if I want to get the same extension, look at my mass. My mass must be increased to 18 kilograms. Then only I will get the same extension from the same spring. Now the next one, number 5, a shopkeeper pours rice into a dish that hangs from a spring balance. This is a spring balance. He records the reading. A customer buys some pasta. The shopkeeper notices that the reading on the spring balance, which just pasta in the dish, is the same as it was with just rice in the dish. Which quantity must be the same for the rice and for the pasta? Now, don't think it like so complicated. What you need to do, like what I told you, there must be a hint given by the question. The hint is this. Spring balance is used to measure the mass. Right. Since this is this customer and this shopkeeper are both on the surface of the earth, W, which is the weight, mass is constant, gravitational field strength is constant. That is why the quantity that must be the same for the rice and the pasta is weight. Because the mass will be the same, gravitational field strength is also the same. Number 6, a student determines the density of an irregularly shaped stone. The stone is slowly lowered into a measuring cylinder, partly filled with water. Which other apparatus does the student need to calculate the density of the irregularly shaped stone? Now, look at the hint. The hint from this question is to calculate density. Do you still recall the definition of density? Density, which is this symbol, rho, is equal to mass over volume. Now, you look at the apparatus. Measuring cylinder is used to measure the volume. So, you have already measured the volume of the stone. And all you need to do is you need another apparatus, which is electronic balance, to measure the mass of the stone. Then everything will just be perfect. So you have to sub in the value of your mass divided by the volume, which is measured by the measuring cylinder, to find the density of the stone. So the balance is the answer. Now, question number 7, a train is traveling horizontally in a straight line. A book is on the table in the train. Diagram shows all the forces acting on the book. How is the train moving? First of all, because the question did not mention that I look at the length. If you have a ruler, to be more specific, you might want to measure the length of the weight, which is acting at the center of the book, and compare with the length of the contact force. Right? I don't think the book will leave the table or the book will be sinking into the table. So I say the upward force, which is a contact force, is being balanced by the weight of the book. So the book is not sinking or floating inside the train. But I want you to pay special attention. The hint is here, frictional force. What is the definition of frictional force? Frictional force is being defined as the resistive force, a force that opposing the motion. A force which opposes motion. That means the book must be moving in order for the frictional force to act on the book. Right. So the frictional force opposing the motion of the book. Therefore, the book must be moving towards the left of the table. Why? Because if the book is moving towards the right of the table, then the frictional force will have to act on the left, towards left. This is direction of motion of book. So what about, okay, look for the hint again. The question asks, how is the train moving? The question did not ask you how the book is moving. Since the book is moving slightly towards the back, which is on the left-hand side of the diagram, then the train must be moving forward. The train move forward. You try to move, you see, you can do that. You're sitting in the car. If the car suddenly speed up forward, what happened to you? You move backwards. Could you see that? Therefore, the train must be accelerating. That means you must apply a force so that the book will slide to the left, accelerating to the right of the diagram. So B is the answer. Now, question number 8. The diagram shows 4 beams, each of negligible weight and freely pivoted. Which beam is not equilibrium? When you see the word pivot, straight away you have to remember, you have to use the principle of moment. Principle of moment states that in order for the object to remain in equilibrium, the total anti-clockwise moment must be equal to the total clockwise moment. First of all, identify your pivot. Okay, for A, B, C, D, I have highlighted my pivot. Second step is to highlight all the forces that are acting on this system. For A, I have 2 forces. B, I have 2 forces. C, I have 2 forces. But D, I have 3 forces right here. Once you have identified all the forces that are acting on this system, you could do it one by one. Now I look at 3 Newton, right? So you know moment causes turning effect. 3 Newton, look at the direction of the force, which is downwards. While going downwards, it will seek for the pivot. It will turn towards the pivot, right? This direction is called anti-clockwise direction. What about the 6 Newton? 6 Newton is going down, but the pivot is on the left-hand side. So the 6 Newton will have to turn towards the pivot. This is called clockwise direction. So anti-clockwise, which is by 3 Newton moment, which is the force. Moment is force multiplied by perpendicular distance from pivot. From 3 Newton towards the pivot, that is 2 meter. So you get 6 Newton meter for anti-clockwise direction for A. And, okay, what about the clockwise moment by the 6 Newton force? Now, the force is 6 Newton and the perpendicular distance from between the force and the pivot, which is 1. So I get 6 Newton meter. Since the anti-clockwise moment is being balanced by the clockwise moment, A is in equilibrium. So A cannot be your answer because the question asks for not, which beam is not in equilibrium. Now, let us look at B. B, 6 Newton going downwards while turning towards the pivot. This is called anti-clockwise direction. Right, I'm going to find the anti-clockwise moment. which is the force 6 Newton times the perpendicular direction, perpendicular distance from the pivot, which is 2. So you get 12 Newton meter. And clockwise moment, I'm using orange color to show clockwise moment. Clockwise moment, it is also 6 Newton, right? But you have to multiply by perpendicular distance between the force and the pivot, which is 2. You get 12 Newton meter. Since the clockwise, anti-clockwise moment is balanced by the clockwise moment, beam B is equilibrium. So B cannot be your answer. What about C? Let us look at C. Now I have 3 Newton here going downwards. While going downwards, it will have to turn towards the pivot. This is called anti-clockwise direction. And 3 Newton the other side, which is going downwards as well. While going downwards, it will turn towards the pivot, which is on the left-hand side. This is called clockwise direction. So I'm going to find anti-clockwise. I'm going to use blue color, anti-clockwise moment by 3 Newton. 3 is the force multiplied by perpendicular distance from the pivot, which is 1. I have 3 Newton meter. And the clockwise moment by 3 Newton as well. 3 Newton multiplied by perpendicular distance from the pivot, which is 2 meter. This is 6 Newton meter. Oh, the clockwise moment is larger than the anti-clockwise moment. This beam is definitely 100%, 1000% not in equilibrium because the anti-clockwise moment doesn't balance by the clockwise moment. The answer is actually C, but I'm going to prove you that D is not the answer. How about that? Now, D, I have 3 forces. 4 Newton towards the pivot, going downwards while turning towards the pivot. This is called anti-clockwise moment. Another 4 Newton, which is on the right-hand side of the pivot, going down while turning towards the pivot. This is called clockwise moment. 2 Newton going down while turning towards the pivot. This is also called clockwise moment. So you have to see this very, very carefully because careless mistake might be occurred here. So I write down my anti-clockwise moment first by the 4 Newton. Oh, sorry. So I'm going to write it nicely here. Moment. Okay, which is 4 multiplied by 2. So perpendicular distance from the 4 Newton to the pivot is 2 meter. So I get 8 Newton meter. And on the right-hand side, clockwise moment by 4 Newton first. 4 Newton, perpendicular distance between the 4 Newton and the pivot is 1 meter, plus 2 Newton is the force, perpendicular distance between 2 meter and the pivot, which is 2 meter. So it is 4 plus 4, which is equal to 8 Newton meter. D is in equilibrium. Why? Because the anti-clockwise moment is balanced by the clockwise moment. Therefore, the answer is C. Number 9, an object of mass 1.2 kilogram is moving with a velocity of 2 meters per second when it is acted on by a force of 4 Newton. The velocity of the object increases to 5 meters per second in the same direction. Wow, this is the hint given, same direction. Remember, velocity is a vector quantity, so you have to be extra careful. Well, for which period of time does the force act on the object? So if the question asks you about the force, just remember F equals to ma. But the problem is I don't have the A. No worries about that. Okay, I use force first. Force is 4 Newton. Mass is 1.2 kilogram and A. A is equal to 4 divided by 1.2. 4 divided by 1.2 and I have 3.33. 3.33 meter per second square. From the definition of acceleration, if you still remember, acceleration is being defined as the rate of change of velocity. Right, since the velocity is just that the object is moving faster in the same direction, therefore the direction of the object, let's say this is an object moving, and after that, it is going to move even faster. 5 meters per second, 2 meters per second. So since the velocities are acting the same direction, no worries. So I sub in 3.33 as my acceleration. Final velocity is 5, initial velocity is 2, and divided by time. So the time would be equal to 5 minus 2 is 3, divided by 3.33. 3 divided by 3.33, and you get about 0.90 second, and the answer is 8. The next one, question number 10. Which row about the change of energy in the system, in the energy store must be correct? Let us look at the process. Water pumped up to a high altitude dam. High altitude means the height is increasing from the ground. The water is going upwards, right? So the energy store will be gravitational potential energy. Why? Because the definition of gravitational potential energy is the energy due to the position of the object measured from ground. Since the water, right, is being lifted up, therefore the height increases and causes the gravitational potential energy to increase. This is correct. Right, let me look at B. Water pump out to a high altitude dam. Energy store is kinetic energy of the water, and the kinetic energy of the water is going to increase. This is not true because kinetic energy of the water is not decreasing because the water is still moving. This is not really true because water pump up to the high altitude. That is not the kinetic energy, right? It is gravitational potential energy. See, air passes through a wind turbine. Okay, when the air passes through a wind turbine, this has nothing to do with gravitational potential energy of the air because the air is not being lifted out to a certain altitude. Gravitational potential energy is related to height, related to altitude. So this is incorrect. D, air passes through a wind turbine, right? Which gives rise, energy store is the kinetic energy of the air. Air just passed through a wind turbine. How can it be kinetic energy of the air, right? That is also not true. So A is the answer. Now, question number 11. A woman of mass 50 kilogram has 81 joules of kinetic energy. What is her speed? Now, the hint is that this is related to kinetic energy. So you have to recall the equation of the kinetic energy. I'm going to write it here. Ke is equal to half mv squared, where m represents the mass, v represents the speed. Ke is given as 81 joules, half, mass is 50, and speed squared. Remember, this is speed squared. So you have to make speed, you have to find the speed, not speed squared. So it's equal to 81 times 2 divided by 50, and you square root the answer. So your answer should be 1.8 meter per second. C is the answer. Now, number 12, a child runs up a set of stairs 4 times. The time taken for each run is recorded. Which time is measured when the child's useful power is the greatest? The hint is here. Now, let me highlight the hint first. Useful power, second hint is greatest. Now, how do you relate power and time, right? Power is being defined as work done or energy divided by time. If I want the useful output power to be the greatest, that means the time taken for the boy to run up the stair, the child to run up the stair would be the lowest. Right? Stick for the lowest time, 10 seconds. Wow, the power, the boy or the child must have a lot of power because the child just used up 10 seconds to run up the set of stairs. Now, question number 13 is a repeated question from other past years. A dam holds water in the reservoir. The height of the water in the reservoir is 15 meters. The density of the water is 1,000 kilogram per meter cube. What is the pressure? Now, when the density is being given, and this is related to water, remember, that's another equation of pressure for fluid, valid to liquid and gas. Pressure is equal to rho GH. What is rho represents? Rho represents the density of the water. So you want to find the pressure. Density of the water is 1,000. G is 9.8. And the height is 15 meters. So I'm going to do it. 1000 times 9.8 times 15, that is about 147,000 Pascal, and you could round it off to 150,000 Pascal. D is the answer. Number 14, a student uses a microscope to observe pollen moving in the surface of the water. You see pollen grains, you see smoke particles. This is related to Brownian motion. Mr. Brown. So Brownian motion states that why pollen grain is moving in zigzag direction, right? Jerky zigzag direction, right? In random direction. It is because pollen grains are being hit by uneven forces by the water molecules. So the water molecules are even smaller than the pollen grains. So water molecules are moved by the pollen grain? No, no, no. That is not the answer because the water molecules are smaller. Smaller particles are moving the larger particles. That is why we can see from the microscope that pollen grains have weird movement, right? So microscopic. Why? Because it is very small. Pollen particles are moved by water molecules. C is the answer. Number 15, which statement about evaporation of water are correct? First one, evaporation causes the remaining liquid to cool. Do you know why this is correct? Because once the higher kinetic energy for evaporation, you have to understand this. Kinetic energy is directly related to temperature. So when temperature increases, evaporation can only occur at the surface of a liquid. So the surface of the liquid molecules will get the heat first, and they absorb the heat, increases their kinetic energy. The kinetic energy increases. When the kinetic energy increases, they have more energy to be escaped to the surrounding. So what about the water molecules of lower temperature? Lower temperature, lower kinetic energy. You see that? So that is why evaporation causes cooling effect. Now, the second, during evaporation, the more energetic particles escape from the surface of the liquid. This is also true about evaporation. The third statement, evaporation only happens at 100 degrees Celsius. That is not true. It is the boiling point of the pure water only happens at 100 degrees Celsius. So 1 and 2, B is the answer. Number 16, some hot water is sealed. Sealed. Okay, this is a hint. Sealed inside a metal can. Okay, this is sealed inside. Be careful. The can is in a vacuum in the outer space. The hot water slowly cools down. How does the thermal energy escape into space? So one of the way of thermal energy can be transferred is by radiation. Because thermal energy can transfer through vacuum, the process is called radiation. So A cannot be your answer. You just tick radiation first. Now, evaporation, if you think it logically, since the hot water is being sealed, that means closed, tightly closed, how can evaporation occur? Because when evaporation occurs, the molecules must be escaping to the surroundings. That is not true. Now, therefore, B is the answer. Conduction means there is a physical contact between hot water and metal. So that is conduction. Number 17, the diagrams show graphs of displacement against time for 4 waves. All the graphs are drawn to the same scale. Which wave has the greatest or largest amplitude and the largest frequency? If you want to see the largest amplitude, you see how tall the wave is. The tallest wave has the highest amplitude. Now, let me see. Oh, it seems like D is a bit shorter. C is a bit shorter. C and D are not the answer. It's either A or B. If you want to see the highest frequency, you look at the time graph, x-axis. How many waves can be formed, right, in a given time? So I could see that A has more waves, more number of waves as compared to B. B, the wave is further away from each other. So that is why A is the answer. Highest amplitude, the wave must be closer, packed together, right? Number 18, the diagram shows a ray of light entering a glass block. Which calculation gives the refractive index of the glass? Now, this is a symbol of refractive index. When the wave or when the light ray travels from the less than, air is less dense as compared to glass. So the equation is psi incident angle over psi refracted angle. But you have to be extra careful. You know why? Because incident angle is the angle between normal and the incident ray. So this is called incident angle. What is normal? Normal is an imaginary line which acts perpendicular to the surface of the glass. So why we need normal? Because normal is an indicator to measure our incident angle or refracted angle. So incident angle would be 90 sine 90 minus 50 divided by refracted angle. Okay, this is normal, this is refracted ray, so sine 25. Therefore, it is sine 40 degrees divided by sine 25 degrees. A is the answer. Number 19. An object O is placed at a point P near a thin converging lens. The diagram shows three rays from the top of O passing through the lens. Each point F is one focal length from the center of the lens. Each point 2F is two focal lengths from the center of the lens. The object O is moved to point Q in the diagram. Which type of image is produced when the object O is at point Q? Now, when a diagram is being given, rather than you guess, I prefer to draw it myself, right? Now I'm going to draw it. Now the object is shifted to point Q. So I'm going to use my ruler to draw it. Okay, point Q. Okay, it is here, roughly about here. Okay, and then once you draw this, you still have to recall the ray diagram. Any ray that passes through, any ray that is horizontal, right, towards the center of the lens will be refracted towards principal focus, or focal point, we call it. Now, let me shift this a bit because I need to draw longer. I just want to draw the same one. It's just that I just draw longer. Okay, don't guess. Just draw it because diagram is given. So I draw longer. Okay, now the second ray diagram is that any ray that is going towards the center of the lens, will just go through straight. That is the second ray diagram. And the third, any ray, actually I have, any ray, the third ray, any ray that passing through the focal point first before the lens, just go straight. This ray going straight towards the, I need to draw it nicely. This is the center. You can extrapolate the line, yeah? Will be refracted horizontally. Might not be very nice, but I try my best. This is, therefore, here you could see intersection of all the rays give you the location of the image. I could see that image is definitely larger and inverted. So B is the answer. Each and every time when you see this, remember ray diagram, you have to draw arrows, right? So each and every time when a diagram is being given, instead of you guessing, instead of you memorizing, just draw it. Number 20, which diagram shows the dispersion of white light by a glass prism? What is dispersion? Dispersion is the spreading of white light into 7 spectrums of colors, right, by using a prism. Right now, dispersion, right, occur because light of different wavelengths. So when the light flowing or passing through a prism, due to the different density, the speed of the light will be different. A cannot be the answer because red light has different wavelength as compared to violet light. Therefore, different wavelength gives you different speed. Inside the prism, it seems that the speed of the white light is still the same. No, it will be separated into colors. A cannot be the answer. What about B? B seems to be correct to me because red light will be refracted lesser as compared to violet light. How do I know? You draw normal. Lesser diffraction as compared to violet ray. Now, okay, after coming out from the prism, red light will have smaller refraction as compared to the violet. Violet will refract even more, will be bent even more. So what about C? C seems to be violet go up and red go up and violet going down. But this is, you see, okay, it seems like the red light is being refracted, right? It seems like violet ray is not being refracted a lot. So C is not so correct. Right. And what about D? D, it seems like, could you see that this ray, right, is going straight, the violet ray. We have a problem with the violet ray because coming out from the glass prism, the violet ray must be refracted away, right? So that is why it seems to be a straight line. So D cannot be the answer. The best answer is B. Number 21, visible light has wavelengths in the range of 4 times 10 to the power negative 7 meter to 7 times 10 to the power negative 7 meter. What is the range of frequencies of visible light? Visible light is one of the electromagnetic ray that travels with the speed of light, remember? Therefore, if you want to find the range of frequency, right, still remember this equation? V equals to F lambda. V represents the wave speed, F represents the frequency, and lambda represents the wavelength. Now, if I want to find the range of frequency, I make frequency as a subject is equal to V over lambda. If I want to get the minimum frequency, wavelength must be maximum, the largest. Now, speed of light is the same, 3 times 10 to the power 8 divided by maximum wavelength, 7 times 10 to the power negative 7. And I got 7.5 times 10 to the power of 14 hertz. Oh, okay, 7. Oh, I'm so sorry. It is not 7.5. That is maximum frequency. Okay, I copy wrongly. So that gives you 4.29 times 10 to the power of 14 hertz. This is minimum frequency. If you want maximum frequency, speed of light is the same, and the wavelength must be minimum. Because after all, when the speed of light is constant, frequency is inversely proportional to wavelength. In other words, when the frequency is the largest, wavelength is the shortest. Now, speed of light is the same, divided by minimum wavelength, 4 times 10 to the power negative 7, and you're supposed to get 7.5 times 10 to the power of 14 hertz. Now, the answer is definitely D. 22, student X fires a starting pistol which produces a smoke and a sound. Student Y standing 100 meters away and see the smoke. The instant it is produced, the speed of sound in air is 340 meters per second. What is the time delay between the student Y seeing the smoke and hearing the sound? Okay, let me draw out the two students. This is student X. Fire, this is a gun. I'm not good in drawing. I hope you can understand. This is a smoke. This is a student Y. Oh, Y is higher, okay? The distance is 100 meter. Right, if you want to find the time delay, you look at the light first. Okay. Speed is defined as distance over time. Speed of the light is 3 times 10 to the power 8. Distance is 100. So I find the time. The time would be 100 divided by 3 times 10 to the power 8. Could you see that the time is 3.33 times 10 to the power negative 7 seconds. That means it occurs super duper fast. Right, so that is why the student Y can see the smoke almost immediately. But for sound, okay, the speed of the sound divided distance over time. The speed of the sound is 340, distance is 100, and the time, right? The time is 100 over 340, and you get about 0.29 seconds. And even though you get the time delay, that means The time delay, that means you take the time, right? When the student hears the sound minus the time when the student sees the light, because the time when the student see the smoke, sorry, not the light, see the smoke, right? It happens too fast. So you will still get 0.29. Now, question number 23. An unmagnetized piece of soft iron is placed close to a strong permanent magnet as shown. What is the induced polarity of NX of soft iron, and in which direction does the magnetic force act on the soft iron? First of all, soft iron is called soft magnetic material. So soft magnetic material is one of the magnetic materials as well. So let me explain this in a simpler way. You know a fridge magnet? Fridge magnet, when you place the fridge magnet on the fridge, right? It is never being repelled by the fridge. It is always being attracted to the fridge. Have you ever wondered why? Right? The reason is here. Why? First of all, the fridge magnet is being made of soft iron. Soft iron is a magnetic material that will undergo a self-induction. What is self-induction? To induce itself, right? To be attracted to permanent magnet. So all you need to do, the tip is that when you see, oh, this is a north pole of the permanent magnet that is facing the X of the soft iron. So the end of X of the soft iron will think, oh, how am I going to be attracted to the north pole of the permanent magnet? So the polarity of NX that will be induced would be south pole. Because after all, only opposite poles can be attracted to each other, right? So south pole. And the direction of force, you see magnet, right? Fridge magnet, you bring close to the fridge, what happened? Oh, the fridge will be attracting the fridge magnet right away, right? So the force is go towards permanent magnet. Towards left is the answer. C is the answer. Number 24, this is also a repeated past year question. A plastic rod is rubbed with a cloth. The rod and the cloth both become charged as electrons move between them. The rod, oh, this is a hint. Okay, straight away. The rod becomes negatively charged. Which diagram shows how the rod becomes negatively charged and shows the final charge on the cloth? First of all, you have learned about two charges, only two charges required for you to learn. One is a negative charge, the other one is positive charge. And out of these two charges, negative and positive, only negatively charged can move. Rod becomes negatively charged because the negative charges, right, from the cloth is migrating towards the rod. So making the rod to have more negative charges. So I want to see electron move towards the rod. A cannot be the answer. Oh, B, electron move to the rod. C is not correct, incorrect, because electron move from rod to cloth. D could be the answer as well. Now, when electrons from the cloth, right, have already migrating to the rod, it seems like the cloth is losing electrons. When the cloth is losing electrons, the cloth would become positively charged because it has lesser electrons. Therefore, B is the answer. Number 25, a wire has a uniform cross-sectional area. Which statement is correct? Do you still remember the relationship between resistance and other physical quantity? Resistance is directly proportional to length. That means the longer the wire, larger the resistance. Resistance is inversely proportional to cross-sectional area. That means thicker the wire, lesser resistance. Why? Because more electrons can flow, right? More electrons flows, that means current will be larger, right? And okay, you have to imagine one more thing. Cross-sectional area of a wire, this is a wire. Cross-sectional area is the area of the circle. A is equal to pi r squared. This is a little bit of math, but you definitely know that there's no apparatus in our lab that can be used to measure the radius of the wire because after all, wire is so small, right? The only apparatus that we could use to measure is called micrometer, but micrometer can only measure the diameter of the wire. So what is the relationship between diameter and radius? Radius is equal to diameter over 2. Sub into the equation, you could have A is equal to pi d over 2. You square it and you have pi d squared over 4. Now, let us look at the statement one by one. The resistance of the wire is directly proportional to the cross-sectional area. No, it is called inversely proportional. This is wrong. B, the resistance of the wire is also wrong. C, the resistance of the wire is directly proportional to the length, which is correct. Inversely proportional to cross-sectional area. C is the answer, but I'm going to prove D is wrong. Resistance of the wire is directly proportional to the length, but inversely proportional to diameter. No, not diameter, but diameter square. Right? Therefore, the answer is C. Number 26, the diagram shows the current voltage graph for a metal wire. What can be deduced from the graph? This is something to do with Ohm's law. Ohm's law states that current is directly proportional to voltage. To get rid of this proportionality, V is equal to IR. So to determine the R is the ratio of V to I. So as the voltage increases, the temperature of the wire will increase. No, if the temperature of the wire increases, then the current will have to decrease. This is wrong. B, as voltage increases, the temperature of the wire decreases. No increase, no decreases. Ohm's law states that voltage is directly proportional to the current, or current is directly proportional to the voltage only if only the temperature of the conductor is constant. Right? So when you see temperature, this is wrong for the straight line graph. C, as voltage increases, the resistance of the wire increases. No, straight line graph will always give you constant gradient. That is why D is the answer. Number 27 is also a repeated question. A battery is connected to a circuit. It is switched on for 1 minute. During that time, there is a current of 0.4 ampere and in the circuit, and the battery supplies a total of 48 joules of energy. Which row gives the charge that passes and the electromotive force of the battery? Charge, if you still remember, Q8. Q is the charge. I is the current, 0.4. Since the charge must be measured in coulomb, the time must be measured in second. 1 minute is equal to 60 seconds, so you get 24 coulomb. A and B cannot be the answer because A and B represents current, not charge. EMF of the battery, the hint is that since the energy is being given, why not just use E equals to VIT? And I want you to pay special attention to this IT. IT is equal to charge. Right? So I'm going to sub that in. Energy is 48. V times 24. V is equal to 48 divided by 24. And the answer is 2 volt. C is the answer. Number 30, the circuit diagram. Number 28, sorry. The circuit diagram shows two identical lamps connected in parallel to a cell. The hint is here. 3 ammeters X, Y, and Z are also connected in the circuit as shown. Which statement about the current is correct? Now, parallel circuit, the total current is equal to the sum of the current leaving the junction, right? So the total sum of current leaving junction. What is a junction? Junction is the point where the current split. The total current is X, sum of the current, okay, Y plus Z. Now let us look at the statement. A, X is equal to the current. No, cannot be equal because this is not series circuit. Now, B, the current X is lesser. No, the current X is a sum. So it is the largest current. C, it is equal to the sum of current Y and current in Z. This is definitely correct. Right, C is the answer. Number 29, a student connects the circuit shown. Which switches must be closed for the bell to ring without lighting the lamp? Bell, this is bell. If I want bell to ring, I have to close this circuit and I have to close the main circuit in order for the current to flow out from here and go to the bell and back to the negative terminal. So it is 1 and 3. So the answer is B. 30, the diagram shows an AC generator. This is a little bit confusing graph right here, but it requires your sharp eyes to see the answer. So the graph shows the potential difference between the point X and Y plotted against time. A positive value of PD indicates that X is more positive than Y. Okay, it doesn't matter. So which diagram shows the position of the coil at point P of the graph? This is AC generator. So this is the output of the AC generator. It consists of positive and negative value. AC, after all, is alternating current, right? Alternating current has both positive and negative directions, right? Now, which diagram shows the position of coil at point P? So the hint is at point P, you get maximum PD. Maximum PD, but in negative direction. Doesn't matter because AC is supposed to turn 360 degrees, right? Doesn't matter. So if you want to get maximum PD, the coil must be in horizontal direction because to ensure that the maximum magnetic fields being cut by the coil to induce more PD across X and Y, right? Look at the graph. B and D cannot be your answer because the coil is in vertical direction. Right. Now, between A and C, I want you to pay very, very careful. Yeah, sharp eyes to see this. Could you see that close to the South Pole, right? Close to the South Pole, this coil is being connected to this side. And then close to North Pole, I want you to see this again, close to North Pole. This end of the coil is being connected to X. Now I check that again, close to North Pole, because the North Pole is on the left hand side, so it has to be connected to X. But A, it seems that this coil is being connected to Y. What about C? C, it seems like, okay, this left that close to the North Pole, right? The end of the coil, which is close to the North Pole, is being connected to X. Could you see that? So it has to be connected to X all the time. C is the answer. Number 31, an electron moves in a uniform magnetic field. The arrow shows the initial direction of motion of the electron. Direction of the magnetic field is into the page. In which direction does a force, you see that? A force acts on the electron. Since the electron is moving, okay, the movement of the electrons indicates there's current, right? So you use Fleming's left-hand rule. Find my cat. This is force, this is magnetic field, and this is the direction of the current. First of all, they told you that the magnetic field is into the page. So your first finger points into the page, right? And then the electron, since the electron is moving towards the right-hand side of the page, therefore, the current must flow in the opposite direction to electron. This is where the current is flowing. Right? So second finger turn towards the left. Could you see that my thumb is pointing downwards? That is the direction of force acting on the electron. It is towards the bottom of the page. C is the answer. This is also a repeated passive. Now, question 32. Which statement about transformer is correct? Are you asking about Bumblebee or are you asking about Optimus Prime? Oops, okay, sorry. So A, there is an alternating current in the iron core. Alternating current is connected to primary coil, not iron core. Right, so this is wrong. B, an alternating current in the iron core. No, alternating current is only in the primary coil. This is also wrong. C, an alternating current in the primary coil. Yes, correct. Induces a direct current. Alternating current will only induce alternating current, AC, in the secondary coil. Right? Never induce the direct current unless you connect a diode to it in the secondary coil. D, an alternating current in the primary coil induces an alternating voltage. Yes, the direction of the alternating current is the same as the direction of alternating voltage. So D is the answer. Number 33, how are positive and negative ions formed from atoms? Positive ion, remember, right? There are two charges. Out of these two charges, positive and negative, only negative charges can move, right? So if you want it to be positive ions, you have to remove electrons. You cannot add positive charge, right? Because positive charges cannot move. Negative ions, if you want to the atoms to be negatively charged, all you need to do is just add electron because electrons are free. You can just add it. You can just move it. C is the answer. Number 34, a nucleus of element X is represented as 5626X. What is an isotope of element X? Remember isotope? Isotope have the same proton number. Where is our proton number? Proton number is actually here. This is called proton number. The one that has the same proton number is B. B is the answer. Number 35, a radioactive source is placed near a detector connected to a counter. 210 counts are recorded by the counter in 3 minutes. The background count rate is 20 counts per minute. What is the corrected count rate for the radioactive source? Right, first of all, this is a count rate per minute. So I have 210 counts per 3 minutes. I want to change it to per minute, counts per minute. So 210 counts in 3 minutes. But I want 1 minute. 1 minute, how many counts do I have? So I take 210 divided by 3. I get 70 counts per minute. And corrected, you see the word, the hint is corrected count rate. Corrected count rate, okay, count rate must be the count rate deduct with your background count rate, right? It is 70 minus 20. So you get 50 count per minute. A is the answer. Number 36, the background count rate measured by radiation counter is 40 counts per minute. With the counter close to the radioactive source, the counter reading is 960 counts per minute. The half-life of the source is 20 minutes. What is the counter reading 1 hour later? First of all, the definition of half-life. Do you still remember? It is the time taken for the radioactive source, to decrease to half of its original value. Since the background count rate is an unwanted count rate, it has nothing to do with the radioactive source. You need to find your corrected count rate. So I have to find my corrected count rate. Initial corrected count rate, yeah? Initial corrected count rate will be initially 960 minus 40. So I get 920 count per minute. And then I plot a table. I do it right here. 920 counts per minute occur at time equal to 0. And then, okay, this is decaying graph. So the count rate is going to be reduced by half. So 920 reduced half. This is 460 counts per minute occur at 1 half-life. 1 half-life is equal to 20 minutes. And after that, it keeps on decreasing to become divided by 2. So this is 230. Okay, this one occur at 2 times of the half-life because you have divided 2 twice. So 2 times 20, which is equal to 40 minutes. And they want the counter reading 1 hour later. 1 hour is equal to 60 minutes. Right? I keep on dividing. Divide 2. So I divide 2, I get 115. This is 3 times the half-life. So 3 times 20, I get 60 minutes. 60 minutes is equal to 1 hour. But you have to look at the question again. What is the counter reading? So you have to bear in mind, the counter is not selective. It cannot select, oh, I don't want to read the background because the counter will come with the background count rate. So if you want to get the reading from the counter, reading from counter, so you have to add back your background radiation. 115 plus the background radiation is 40. So you get 155 count per minute. C is the answer. So you have to be aware with that. It is quite tricky actually. Number 37, which planet in our solar system is nearest to the sun? And what is the nature of the planet? Right, the four planets which are closer to the sun, Mercury, Venus, Earth, and Mars, they are called small planets. And the nature is they are rocky planet. So the planet which is closest to the sun is called Mercury. A is the answer. Number 38, a space station orbits the Earth at a distance of 7,000 kilometers from the Earth's center. It makes 15 orbits in every 24-hour period. What is the speed of the space station in its orbit? Okay, this is the Earth. Okay, this is the space station in its orbit. And the distance, right, is actually the radius of the orbit. Distance measure is 7,000 kilometers. Right? So speed, so remember this is orbital speed because this is orbit. So the hint is orbit. Orbital speed is equal to 2 pi r over t. Now, r is not the radius of the Earth. You have to be extra careful. R is called the radius of the orbit. Right, so 2 pi, radius of the orbit is 7,000, but I'm not going to change the kilometer to meter because the answer, the speed is measured in kilometer. But this space station orbits, 15 orbits in 24 hours. I only want one orbit because T represents period. Period represents the time taken for one full orbit. Right, so I put 15 orbits is equal to 24 hour. I want one orbit. Cross multiplication. So 24 divided by 15. One orbit is about 1.6 hour. So just put 1.6 here. Hour. Right? This is kilometer. And then you should get your answer. 27,489 kilometer per hour. So you round it off to 27,000 kilometer per hour. D is the answer. 39. Which nuclear reaction powers a stable star? A stable star meaning to say that the process of fusion has already occurred, and the process of fusion, the outward pressure by the process of fusion is balanced by the inward pressure caused by the gravitational force. So the nuclear fusion occurs when the hydrogen nuclei, right, fuse together to produce helium. Right, D is the answer. Now, number 40, which stages in the life cycle of a star are listed in the order that they occur? Let us look at A, right? A is wrong because protostar come first before the stable star. This is wrong. B, right? Stable star is, okay, before the red giant. This is also wrong. Now, C, protostar must be the first one because it is a nursery star. D, a stable star after the protostar, that is a stable star. This is valid to our sun, right? And the sun will become red giant, and after the red giant, towards the end of its life, it becomes a white dwarf first, right? Before it ends its life. So D is the answer. So I hope that my explanation makes you understand. But if you still have any hesitation, you could always comment below. If you need my sample answer, all you need to do is just to hit that subscribe button and comment yes. Thank you very much for watching.